Two compliance clocks expire within 24 hours of each other. Your AI agents either carry a badge or your organization fails both tests simultaneously. This is Chapter 9 of Zero Trust Thursday, the identity control that every other layer depends on. Here's the structural problem. Non-human identities now outnumber humans 144 to 1 in enterprise environments. Service accounts, API tokens, OAuth credentials, AI agent contexts, most are unmanaged, many are forgotten. But here's what changes everything. On 30 April, MCSS mandatory entities must demonstrate identity governance to NCSC. On 1 May, IPP3A takes effect. Every indirect AI agent collection triggers a notification obligation. Same architectural problem. Two regulatory instruments, 1 day apart.
Let's get into it.
I'm Andreas Hamberger, and this is EA Thursday, Zero Trust Architecture for the Agentic Enterprise. Chapter 9 addresses the identity layer, not human identity, which is architecturally a solved problem. Non-human identity, the service accounts, API tokens, OAuth credentials, and AI agent contexts that have accumulated across your environment faster than any governance process has tracked them. Security vendor research, including intelligence from Trend Micro and Asterisk Security through early 2026, indicates these non-human identities now outnumber human users by as many as 144 to 1 in typical enterprise environments. One human user, 144 credentials, integrations, and agent contexts across their digital footprint, most of them unmanaged, many forgotten, some never properly scoped in the first place. The economics of compromise scale accordingly. When an attacker targets a human identity, they gain that person's access. When they target an agent identity, they gain that agent's access. The full scope of everything the agent was authorized to do, across every system it was permitted to touch. The blast radius is not determined by who the attacker is. It is determined by what the agent was allowed to do. On 27 January 2026, the security community got its clearest view yet of what a large-scale AI agent identity failure looks like in practice. OpenClaw, an open-source AI agent framework, had accumulated more than 150,000 GitHub stars within weeks of its January 2026 release. Its marketplace, ClawHavoc, allowed developers to upload skills extending the agent's capabilities. By the evening of 27 January, attackers had begun uploading malicious skills. By 29 January, KOI security researcher Oren Yomtov had audited all 2,857 skills then available and identified 341 malicious entries. Of those, 335 were traced to a single coordinated operation tracked as ClawHavoc. More than 135,000 public internet-facing OpenClaw instances were exposed. The skills carried obfuscated shell commands, installing InfoStealer malware, AMOS for macOS, with credential harvesting variants for Windows. Two CVEs defined the attack surface. CVE 2026-25253 scored CVSS 8.8, enabled cross-site WebSocket hijacking, giving attackers one-click remote code execution via a malicious link. CVE 2026-28363 scored CVSS 9.9, exploited a bypass of the tools.exec.safebins validation via GNU long option abbreviations, creating a confused deputy scenario in which the agent executed commands outside its intended permission set. The incident validated the lethal trifecta from Chapter 5 with precision. The compromised agents had data access to file systems and credentials. They had untrusted content exposure via the marketplace skills mechanism. They had communication ability, API calls, and network egress. All three conditions were simultaneously present. The identity layer was the control that could have constrained the impact. The SalesLoft Drift OAuth breach of August 2025 illustrated the same principle from the opposite direction. Compromised long-lived tokens issued to the Drift AI chat agent remained valid for months after the initial intrusion, enabling attackers attributed by Google Threat Intelligence Group and investigated by Mandiant to access data from more than 700 organizations. The attacker did not need new credentials. They used the credentials that had been issued and never rotated, A token that expires in 15 minutes is not worth stealing. A token that is valid indefinitely is worth everything that agent is authorized to touch. Information Privacy Principle 3. A. Effective 1 May 2026 under the Privacy Amendment Act 2025 establishes a notification obligation for agencies collecting personal information from sources other than the individual themselves. When an AI agent scrapes a public source, aggregates data from a third-party provider, synthesizes information from a document repository, or processes personal information from any indirect source, the collecting agency bears the obligation. 3 architectural questions follow directly. First, which agents are collecting? An agency that cannot enumerate its non-human identities cannot enumerate its collecting activities. Second, from where are they collecting? The notification obligation applies to indirect collection. You must be able to trace the data source for each agent collection event. Third, have individuals been notified? The Office of the Privacy Commissioner's published guidance makes clear that an agency must be able to demonstrate the basis on which it determined that notification was required or that an exception applied. If you cannot find the notification record, you have not satisfied the obligation. The MCSS reporting requirement and IPP3A are not separate compliance problems with separate solutions. They are the same architectural problem expressed through 2 regulatory instruments, closing 1 day apart. The architectural response to the 144:1 identity surface requires 5 implementation components. These are not sequential phases. They operate in parallel, and gaps in any one create exposure across the others. Discovery and inventory, automated scanning of all cloud environments, on-premises systems, and third-party integrations to enumerate every service principal, service account, API token, OAuth credential, and agent context. The goal is complete visibility, no shadow identities, no forgotten service accounts with legacy access, no API keys issued for a project that ended 2 years ago, still sitting in a configuration file. Discovery must run continuously, because new agents are created faster than manual processes can track them. Lifecall governance. Every non-human identity must have a defined birth-to-death record, when it was created, by whom, for what purpose, what it is authorized to do, and when it expires. Automated secret rotation and certificate renewal are the operational disciplines that enforce life cycle boundaries. Long-lived credentials are not a convenience, they are a risk accumulation device. Zero standing privileges. The OAuth token model, in which a token is issued and remains valid until explicitly revoked, creates a window of indefinite risk. Zero standing privileges moves the model to just-in-time access identity issued when the task starts, scope to what the task requires, revoked when the task ends. An agent that has no standing token cannot leak a standing token. Workload federation. Static API keys embedded in code are the single largest identity security debt in enterprise AI deployments. Workload federation replaces them with trust-based identity sharing between environments. Azure Workload Identity is the current NZ cloud-relevant implementation. The Swift/Spire model, introduced in Chapter 7 and developed fully in Chapter 17, is the open-source implementation of this principle. Behavioral anomaly detection. A compromised agent identity does not announce itself. Behavioral monitoring tracks the semantic patterns of agent API calls, volumes, frequencies, data access sequences, and egress destinations against a baseline of normal operation. RSA 2026 conference reporting from multiple security vendors cited at least one case in which an agent had rewritten an organization's security policy to remove restrictions preventing task completion. An agent operating outside its semantic baseline in that way is detectable if you are monitoring for it. The technical artifact in today's full article implements a policy enforcement point for IPP3A compliance, structured as an open policy agent, policy consistent with the NZ-ISM compliant authentication scaffold from Chapter 7. It operates as a pre-collection gate. Before any agent collection event proceeds, the policy checks is the agent registered in the NZ-ISM inventory with a human owner and a token TTL of 60 minutes or less. Is the collection source documented? If personal information is present and the source is indirect, has a notification record been created for this data subject and this collection purpose. Every decision permit or block generates a provenance record that satisfies MCSS Standard 8 logging requirements and provides the audit trail IPP3A compliance demonstration will require. The policy assumes three things exist before it can operate: a populated NHI inventory, a notification registry, and an active session store. Building those is the NHI security strategy. The policy is the enforcement layer over it. Pillar 1 of the AI enterprise architecture model, agent personas, is the governance framework that makes the NHI security strategy operable. An agent persona is not a defined username. It is a defined identity contract, explicit ownership tags, recording which human and which team is accountable for this agent, data provenance chains specifying which sources this agent is authorized to collect from and under what conditions, decision authority boundaries, defining what the agent can do without human confirmation, and a declared purpose that scopes every collection, processing, and communication action the agent is permitted to take. NIST's National Cybersecurity Center of Excellence published a concept paper on AI agent identity and authorization in March 2026. The paper frames implementation around four pillars: identity and authorization, security controls and risk management, testing and evaluation, and interoperability. The NIST framing confirms that the architecture described in Chapter 9 is the direction international standards are moving toward. NZ practitioners do not need to wait for those standards to finalize. IPP3A and MCSS are already creating the compliance requirement that those standards will eventually codify. With 30 April and 1 May approaching, the readiness test for this architecture is practical and specific. 5 questions. If you cannot answer all 5, you have work to do before the clocks expire. First, can you enumerate every non-human identity in your environment, including service accounts created before your current IAM governance was in place? If not, start with automated scanning. The scan result is your inventory baseline. Second, does every agent identity have a defined owner, a stated purpose, and a token TTL of 60 minutes or less? Identities without owners are governance voids. Long-lived tokens are standing liabilities. Both must be remediated before they can appear in a provenance record. Third, for every AI agent that processes personal information from indirect sources, have you created a notification record? IPP3A applies from 1 May. The OPC's published guidance provides the decision framework. If you cannot find a notification record, you have not satisfied the obligation. Fourth, is your MCSS Standard 8 logging configured to capture provenance metadata for agent collection events, not just authentication and access events? For IPP3A compliance, that logging must include the provenance fields, source type, source URI, personal information flag, notification status. The provenance record schema is in today's full article. Fifth, have you run the NCSC CMM self-assessment? And do you know your current maturity level for standards 3, 6, and 7? Asset management, identity and access, and least privilege. These 3 standards are the dependency chain. You cannot scope access without an inventory. You cannot enforce least privilege without verified identity. 4 weeks before the reporting window closes is enough time to document existing controls and assign ownership to gaps. It is not enough time to build what does not exist. The New Jersey Judiciary's Zero Trust Exchange implementation delivered a reported $10.7 million return on investment by securing virtual courtrooms while reducing infrastructure costs. The City of Los Angeles onboarded 18,000 personnel to a zero trust architecture in under 2 weeks during the COVID-19 response. These outcomes are what the architecture delivers when the identity layer is properly governed. The constraint is never the technology. It is always whether the identities have been inventoried, the purposes have been declared, and the provenance records have been created. Chapter 9 establishes the identity layer as the governance foundation. The rest of the Zero Trust stack depends on. Chapter 10 builds the transparency layer above it. When agents make decisions affecting individuals, how does your architecture capture the reasoning chain? That is the logic logging problem, and it requires the identity layer to be solved first. You cannot audit a decision without knowing who made it. Chapter 11 addresses the protective security requirements and cloud jurisdictional risk. Where physically and legally can your agent workloads run? An agent persona that authorizes collection from offshore cloud sources may conflict with data sovereignty requirements. Chapter 11 maps where those conflicts arise. The identity layer is not a feature, it is the prerequisite. What is the oldest long-lived credential in your environment? And do you know what it is authorized to do? That is the Hamberger report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.
Like and subscribe.